So, hello everyone and welcome to the webinar Energy from Waste Needs CCS, here with Captimise. So today I am the CEO of a company called KLIMPO, Climate Positive and Carbon Sinks. And you at Captimise are one of our
for making business out of carbon removal from the atmosphere at Stockholm Exergi.
Good.
And I will come back to more in my presentation, obviously.
Yeah. And you, Martin Redén from Captimise, I'm sorry. Can you tell us a little about yourself?
Yeah, yes. I started with CCS actually 2007 when it was really hot. Norway was kind of the driver country for CCS. So I was working there for 6 years, and during these 6 years, everybody was booming up to the COP15 in Copenhagen, which was a total disaster. So after that, we had what we call the desert walk until 2015, when we actually had the Paris Agreement, when everything kind of rebounced. So since then, we have formed this company, Captimise, which is an independent advisor, where we have people from the industry, from Alstom, from Vattenfall, from ourselves, we came from 2 different companies. So basically, we are a team of professionals within CCS from different companies. We used to be competitors,
all right,
but now we are independent advisors for the emitters so they can find the best solutions.
And you're the CEO of Captimise?
I'm the CMO actually.
CMO, all right.
Yes.
And you also work a lot with logistics regarding CCS.
Yeah, I work with logistics, Vattenfall, for even longer years. More
a lot of years here.
A lot of years. So, and then we have Martin that's living in England, and we have a few people more that's actually engineers working to help emitters.
Yes. And then we get to you here, Martin. Martin
yes.
times 2 we have here. But
Indeed.
your last name isn't Redén, it's Jones.
It's Jones, that's correct.
Yeah. And can you tell us a little about yourself?
Well, I'm Director of Business Development for Captimise in the Nordic region, which is already exceptionally well served.
Yeah.
My background is initially in financing, and then I got into financing with a power developer based in the UK. Then got involved in project development. I've spent a bit of time in privatizations, working with privatizations in Africa, and I've also been involved in some transmission and distribution activities.
Okay. That's really good, yeah. So we have different people here talking about CCS. But we have a target in Sweden to become climate positive in 2045 or net zero. And in the UK, you also have the same target, but in 2050.
That's correct.
But I was wondering about this CCS requirement to have a CCS at waste energy or energy for waste companies.
We'll come to this later. There was a government policy statement which came out in November last year which seems to suggest that that's the direction in which they're moving.
Okay.
Voluntarily or otherwise, we'll have to wait and see.
Okay. But I think that's really important, and also for the other countries about CCS. But it's really important to reach the target. But that you will also talk about later on. But now we will have the first presentation, and it's you, Martin Rödén from Captimise, and you are going to talk about the CCS full chain.
Yes.
Yes, so
Exactly.
This will be really interesting. And then afterwards we will discuss your presentation. And I will tell you guys that you can send us during these presentations, but it is in the end that we will choose.
Yes. Excuse me. So I'll just start very briefly. We are working in Sweden and in Germany for the time being, looking at helping out a lot of different emitters. You see some brands here, and we basically put ourselves in their position and look out how do we want to handle a CCS requirement coming up. And what's interesting is that a lot of companies, the target, the hard stop is 2045, but basically a lot of companies are trying to move ahead of that, so they want to go out 2030 or so, and Stockholm Exergi is of course the leading star here with 2025, so you talk more about that. We also have a long history, like I said. Here we have 10 different demonstration plants that we have built in the team of Captimise over the years in the US, in France, in Europe, in general, where we have built a lot of demonstration plants. And this is one of our business units that we do right now, that we sell demonstration plants. So basically, our history in Sweden started with Stockholm Exergi, where we have been working closely with them for their whole development, including technology screening study, pre-feasibility studies, all the way through, and we actually supporting Stockholm Exergi, who is actually the leading, like I said, the leading star. And they also got the one of the 7 projects who achieved the European Innovation Fund funding this year. So Ursula von der Leyen was here in Stockholm about 3 weeks or a month ago to do this. Basically, what we say is that we can help emitters to cut the cost of CCS. Our whole mission is to cut the cost of CCS, and you can do that in a lot of ways, but we will give you some advice on how you can do this. So the first thing that we want to do, what we say is like, this is overview, full chain, but I'll talk a little bit more about that. So basically, you have to look at carbon capture as a full chain of events, and it's quite a long chain. So it starts with capturing CO2, then you have to liquefy it, you have to buffer storage for a while until you have some kind of vehicle picking it up, and normally it can be a train, or it can be a ship, or it can be a pipeline. And then you have another buffer before the next part of the chain picks it up, and then finally you have to store it somewhere. So it's a lot of different parts of the chain, and you can say that basically transport and storage is 50% and capturing and liquefaction is 50%. So just to get an idea that it's not only capturing, it's a long chain of event, and you have to look at it from the front to the end, basically, in order to understand this. So the other thing that you have to do when you start looking at the CCS project, that this you have to lift your eyes and think about what do you really want. Why am I doing this, and what should be the key performance indicators for setting up a CCS system? So, and of course, this will be something that everybody has a different view of, but I'll give you some ideas that could be of interest. The first thing is timing of the operation. When do you want to get ready? Is it 2025, or is it 2035, or 2028, whenever? That's kind of a set up some kind of deadline when you want to be operating. The second thing is if you want to be using mature technologies, or if you want to actually be part of the development scheme, there's a lot of different technologies being developed, and maybe you want to be part of that, and you want to look at new technologies because you think that new technologies may be cheaper than existing technologies. So that's also, and then it's called a TRL level, technology readiness level, and you may want to say only TRL 8 or 9, or you want to say, well, we want to start doing this together with a developing company. So that's really important as well. Second, the third thing is actually to look at the risks, and that's of course the HSE is called as a health. It's like I don't know what you say in England. Actually, I don't think you have the same abbreviation about health, safety, and environment. Anyway, the risk around health and safety and environment has to be looked at, and you have to think about the permitting process. And there's a lot of stuff in permitting. I'm sure most of you know a lot about permitting, but that's really local, and that's really a headache. So you have to look at that as well. And then, of course, you have to look at the margins, because it's going to be CCS, it's a lot of cost. So you have to think about how to cut the cost, and that's really important to do that. And then Erik will come here and tell you how you're going to make money on this. But to actually look at the income and the cost and put up some kind of view on that is really important. And then local influencers. Basically, when you start talking about CCS, you will have a lot of information, a lot of interest from the community, what you're going to do and so on. And that's also something that is quite important to think about, because it's like opening a box and then you're going to be stars all of a sudden. So I'll start looking at a little bit of the technologies. These are TRL 7 to 9. That's as high as you get within carbon capture. So we will talk about the most mature ones. These are these three. I will tell you a little bit more, but there are approximately 20 more technologies that is kind of being developed right now. So these are not there alone. All these three are basically post-combustion technologies. So they can be hooked on to an existing plant. And they're basically all three the same basic technology. You can see in the middle there, you see two towers or two tubes. Those are the absorber and the desorber. And the difference between these three technologies is actually the absorbent, the liquid that's actually reacting with the CO2 in the flue gas. So it works like this. You get the flue gas, it bubbles up to the left on the left column, and it reacts with the CO2 reacts with the absorbent. And then on the right column, you actually boil out the CO2. So it's very simple. You capture it and then you boil it out, so it actually comes out as a stream. And the difference here are basically, so chilled ammonia is one absorbent, amines is another absorbent, and potassium carbonate it's a third absorbent, but they work the same. And we advise you about we do the calculations of how much it will cost for your plant, and it will be different for the different technologies, but we cannot say that one is better than the other one before you have tested it. So basically the other thing, so that's kind of the front end of this chain. The end point is actually where you're going to store it. And that's really an important part as well, because actually you want it to be stored forever. Really forever. That's kind of the end game. So you actually take the CO2 molecules, you put them together in a liquid, and you ship them out into the sea, and you find a place where you put them, and then you pump it down underground, and they will be stored forever. Between 2,000 and 3,000 meters in depth, they will be stored forever. And there are three different, or you can say 4 different types of storage sites or storage types. There are depleted oil fields, there are depleted gas fields, and then basically the fields there are no longer gas and no longer oil there, so they are filled with water. So you will pump down in the old well, you will, instead of pumping up the oil, you will actually pump down CO2 in it, and the field will actually fill up with CO2. And it will stay there forever. It will eventually also trickle out into the so-called matrix around the field, and it will actually turn into new rock. But that will take a few 100,000 years. And then you have another type, and that you can see as well in the Northern Lights or in horizontal energy. There you have another type of storage, which is saline aquifers. And saline aquifers is basically, you can say it's a field. It's the same. It's a porous rock where you pump down the CO2 and it will trickle out in the sandstone, which is filled with water, and it will just fill there. So it will be kind of, water. It's like carbonated water that will be the end, but it will still stay down there. So why will it stay down there? Well, it stays down there because we have this cap rock on top of this porous sandstone, and the cap rock is really there, and it is like a cap rock, and it will actually, the CO2 will not be able to come back up to the surface. So it will stay down there forever. And then you can see up to the left you have Iceland, and that's CarbFix, and that's a really interesting new technology for storing CO2. Basically, a volcano, and Iceland is basically an old volcano, a lot of different old volcanoes, and the lava that comes out from the volcano is actually it's a rock called basalt. Basalt is formed by a few minerals or a number of minerals, but there are iron oxide, there are calcium oxide, and there are magnesium oxide within this basalt. And these three oxides actually react with CO2 on a natural way. So basically, what happens is you take the CO2, you ship it to CarbFix in Iceland, and there you basically pump it down into this lava rock, and the lava rock, it will actually form into new carbonate rock. So it will not be stored as in the other place. It will actually be stored in a new rock. So we call it mineralization, and that's really another type. So this is really important for you then to understand how you want to do this. But basically, all of these sites, and right now there are 10 sites for storing, and all of these sites have their funding in place. They will be live, and you can see they will be live between 2024 and 2026. They all will be live approximately at the same time. They all will be having sufficient volume to store all the CO2 that we have in Europe, without any doubt. So you don't have to be worried about there will be no space there, but you do have to put yourself up on the list, on the waiting list, and you should do that as soon as possible. But that's something that's more in detail. But so right now there are 10 storage sites. There will be more storage sites. We will get some storage site probably in the Baltic Sea and on land as well, but that's not yet. There are no yet other projects. So these 10 projects are actually the ones that's up and running or will be running by 2024 and onwards. Oops. All right. So the third thing that we want to talk about is don't jump to conclusions. Basically, there's a lot of things to learn, and don't fall into the hands of one supplier or anything like that. You have to basically do your homework, and the only way to do that is actually to do a real study. So you have to study your plant, you have to study which different types of technologies there are out there. You have to think about where you want to store it, and then once you have decided where you want to store it, you can look at the transport side. In England, you have a very different situation than in Sweden and in many other countries, because you have your clusters. So we'll talk more about that, but of course the clusters are there, and that's a very convenient thing because the clusters are already being developed in England. But it's not sure that maybe you sit in a place where it's far away from a cluster, then you can basically take the train, put the CO2 on the train and go to harbor, and then go directly with a ship to Carbfix. That's an opportunity or an alternative to you. So all this stuff have to be studied, and so don't jump to conclusion. That's basically the story. So when you do these studies, the first thing you have to do, or you want to understand, is how much is this going to cost? I mean, that's really the important part. So we do the study. We start with doing heat and mass balances on the plant for 3 different technologies, and we get the capex, the opex, and the whole chain for transport. And then of course we don't add the storage, because the storage price will be something that you will negotiate directly with the storage facilitator, because it's actually your molecules that will be stored in underground. It's not, so you have to take care of the whole chain and actually assure that your molecules are stored. So but the transport side, the transport you have to look at. So to the right you see some of the variables, but I'm not going to go through them, but that's what we look at. The flue gas, the properties of the flue gas, how much O2 and how much NOx, how much percentage of CO2 and so on. And we do the calculations, so after a study you will know exactly what that will cost, plus or minus 30-40%, something like that. And then after you do the first study, you have to do another study. Once you know the weak points, you will do another study, and then finally you will do a feed study, and then you will get a plus minus maybe 10 or a fixed price on the feed study. This process takes about 6 to 7 years before you're up and running. So it's a long way to go. So you have to start fairly early and look backwards. So another thing that we say is the contractual strategy. You will actually don't sign any NDAs with capture technology providers. Don't do that. Don't do that until you know that you want to buy something from them. So ask about information without NDA. That's really a very important thing. Don't jump into the hands of people. Second thing, don't decide on a purchasing strategy before you actually know what you need and want, because you can purchase this as with an EPC contractor, you can purchase this as an EPCM contractor. There is even now companies who wants to deliver this as a service, that you can actually buy it as a service, or you can buy it as cost per ton service. So these are being developed right now. So you have to wait and see till you really want what you really want. And then of course there is a logistics scenario, and you have to look. Don't do anything about that either to decide until you have checked with your local emitters around yourself, because the only thing we can say is that transport is a volume business. So if you basically can join forces with your fellow emitters in your neighborhood, you will be able to decrease the cost of transportation. So what we do package studies. We will help emitters doing studies, and we developed demonstration units. So this is a demonstration unit that we have developed. It's a two-story unit where you have the control functions, and we can create steam and so on, and then you have the columns, and these are kind of the 2 columns that we talked about. They are divided in 4 because it's actually each column is divided by 2, because you don't want to climb up 40 meters in the air if you want to fix something. So it's just practical. It's just divided in 2. But basically we can then demonstrate amines, we can demonstrate potassium carbonate, or we can demonstrate chilled ammonia. It's 2 containers, and we can demonstrate by defining the reactions of the flue gas, which is very good to do before you start buying a 200 million euro plant. You may want to see how it will work in real time with a much smaller plant. The other thing you can actually see is capture rate performance. You can optimize the solvent. I mean, this absorbent fluid, you can actually optimize it, and you can put in new catalysts. And you can, very importantly, you can actually review the purity of the CO2 stream. And that's important when you go out, if you want to have a pipeline, or if you have a train, truck, or a tank, you want to know that there is no, for instance, no other metals in the flue gas, that it's clean from different type of impurities that will actually put problems in a pipeline further down the line. And there will be requirements on your CO2. So a demonstration plant is also good to look at the purity of your CO2. And then, of course, it's a lot of PR. I think Erik will tell you more about that. A lot of PR around that. I will not tell you much about the business model. That's your business yourself. But what we can see is that basically you can sell carbon removal credits. You can avoidance of ETS cost if that will be applied in England. Of course, you will have a gate fee you have already, but you can actually have gate fees with negative emissions instead of just gate fees. And you can have, if you have district heating, you can actually also sell district heating with negative emissions. And then the question is, the CRCs, what will they, how much will you get? Well, basically, I will show this is like a crystal ball. Nobody knows what the cost, how much you can get. But Erik will talk more about this. But this is basically Goldman Sachs, and in The Economist has showed a little bit about what other emitters have to pay to capture their cost, to avoid. And there you can see there on the right side, you see the scale. And basically you can see that it goes up to 1.2 1,200 euros per ton. So, and the blue one on the right, that's basically transport. But then you see buildings, heat and cooling, and industry in general. They will need to pay a lot to capture this technology. So if you can sell negative emissions to them, it's actually an opportunity. So basically, I can see opportunities with CRCs, but thankfully, we have now a specialist within this industry here in the studio. Erik, can you tell us a little bit more about this?
Yes. So
wait a minute.
Okay.
We're just going to discuss your part first.
All right.
Wait, Martin, are you finished?
I'm finished. Yeah.
Really good. Thank you very much. But I just wanted to ask you, if I have an energy from waste plant, how do I start with a huge project like CCS? How did you start? How do I start? Do I contact you, or what do you do?
Well, first of all, I think that you have to look at your own plan.
Yeah.
When do I want to do this?
Yeah.
Do I want to do it 2030, or do I want to do it in 2045, or do I want to do it like Erik 2025? So that's kind of the first thing to see, my plan. And then maybe I should talk with my fellow emitters in my region, because it's quite good if I start at the same time as they do.
All right.
Because then we can communicate we can put the CO2 together. Then you have to do the studies. Once you know your end point, you can start doing the studies.
But you can also contact you at Captimise for these pre-studies. And I know also we are involved in different CCS projects, and it's not just only the technical part and the logistics. It's also a lot about communication to get acceptance, and also the permits, as you mentioned. But that's really good. And how did you start at Stockholm Exergi with CCS or bio-CCS?
Well, actually, I will talk more about this in my presentation, but I think that we recognize that negative emissions is something that will be needed in the future to be able to reach the Paris Agreement or the targets of the Paris Agreement. And we also saw that the infrastructure that we already are in possession of, large bioenergy plants, is very suitable for applying this kind of technology. So it would put us in a position where we can actually use what we already have and just add this extra value, creating negative emissions. Apart from just supplying power and heat, which is normally what we do, we will also supply negative emissions together with power and heat. So it's a way to optimize what is really already ongoing. And we saw that opportunity, and that's the opportunity that we are now developing.
Yeah. And that's really good. And you are also helping, like Sweden, to reach our targets to become climate positive in 2045.
Yes. I mean, in order to reach net zero, first of all, we will need to drastically reduce emissions.
Yeah, but
I mean, that's the major chunk.
Yeah,
85, I would say 90-95%. But it's recognized that around 10, maybe 5 to 10% of the emissions that we have today will be very hard to abate or very, very costly to abate. So for those emissions, it will be logical to apply technical carbon removal. So basically taking carbon oxide out of the atmosphere that has already been emitted, in order to reverse what we have, what we cannot stop from happening. So even if carbon dioxide is emitted after we have reached the targets in 2020, 45 or 50 or whatever, we have our net zero target, we need first of all to compensate for what we cannot stop emitting at that time. But we also will most probably be in a position where we have already emitted too much. So we need to reverse, to clean the atmosphere. And this is basically the only technology we know of today that could accomplish that.
Yeah. Yeah, also we have to clean the atmosphere. That is a really, really good point. And I was also thinking about you. We talked about these requirements, and you, Martin, you also mentioned something that they should think about this. But what if it becomes a requirement for all the energy from waste plants to install a CCS? Isn't it better to be prepared to create good conditions and to analyze this now?
It's always better to be aware of the environment you're operating in, certainly. And I think I'd be surprised if there's any waste-to-energy plants that are not following this quite closely at the moment, just to see what the government says and any nuances and any announcements that are made. I'll talk about this a little bit later on in brief. But yeah, it's a combination of awareness and considering what the available options are. Then if it suddenly becomes fact and hits, and it is mandatory, you've already partway there of having an understanding of what might be required and how you might go about it.
Yeah, and a really good thing that we also should mention here is that it's a new industry growing. And you at Stockholm Exergi, you did a report about job opportunities. Like in Sweden, it will create like 28,000 new jobs. And also our competence is developing, and it's the same in UK, isn't it?
It is.
Yeah. So that's really important. But now we're going to dig more into costs. Or credits.
Exactly. How to make business out of carbon removals. I think that is what I will talk about, because we all know that these technologies, they work.
Yeah.
They have been proven over a long period of time. Martin has told us about the TRL level being between 7 and 9 for the main technologies that we see today. So that is not really the problem. We know that we can do this, but in order to invest in these plants, we also need to secure revenue. So revenue that could give us a business case that would make this a viable investment. So that is really one of the big challenges that we are facing as we try to establish this new industry of negative emissions. So this is really what I will talk about. So first, just some brief things on Stockholm Exergi. Stockholm Exergi is a district heating company operating in Stockholm. We are the largest district heating company in Sweden. You see some numbers here. We are 50% owned by the city of Stockholm and 50% by private pension funds. Already today, our production is based on 99% our production is based on either recovered, reused, or renewable energy sources. So only 1% is fossil or the traditional fuels. But we are not content. So from here, we're now moving on to removing carbon dioxide from the atmosphere. And just like Martin said, I mean, we aim to have this first large-scale plant up in operation by 2025. And at that point, our total production chain would be net negative. I mean, we would remove more carbon dioxide from the atmosphere than we are placing there from our running operations. And this will give us the opportunity, obviously, to also sell negative emission credits to other companies that want to use them. So BECCS, we are working with BECCS. BECCS is then bioenergy carbon capture and storage. This is a bit different from if you would place CCS on a waste plant, as the waste is not totally biogenic. With BECCS, you have 100% biogenic fuel to start with. And this is the project that we are developing right now in Stockholm. So why do we need BECCS? I think we already touched upon it a bit, but and what is BECCS? Maybe we should start there. So you see an illustration here on my slide to the left, and BECCS is really about removing carbon dioxide from the atmosphere and putting it away permanently. So, and how do you do this? Well, you actually use the fact that trees and plants, as they grow, they will naturally absorb carbon dioxide from the atmosphere over the photosynthesis. So the carbon is bound in the biomass. When we use biofuels, and in the case of Stockholm Exergi, we use quite a bit of biofuels, but only residues from the forest industry. Sweden has a large forest industry, so there is plenty of residue or rejects from this industry available in Sweden that we use as fuel in our bioenergy plants. And then the carbon dioxide that is released as you incinerate the biofuel is actually the same carbon that was once absorbed by the plants. So it has been taken out of the atmosphere, and now we have it in our plant. And when we capture that carbon dioxide before we release the flue gases, we have actually taken that carbon dioxide away, and then we put it underground, just like Martin described earlier, and it has been removed permanently. It's actually reducing the concentration of carbon dioxide in the atmosphere. And is this necessary then, you can ask yourself? Well, as I also said in the beginning, we are not going to solve the climate problems just by removing carbon dioxide. We need to reduce the amount of carbon dioxide that we emit. So solving the problems of the climate and reaching the targets of the Paris Agreement is to 90 to 95% about reducing the emissions that we have today. So stop emitting carbon dioxide. But as I also said before, there will be a remaining part that we will not be able to get rid of, that we need to balance and neutralize with negative emissions. And there is, for the case that we end up in a situation where we have already emitted too much to reach the 1.5 degree target, which is very likely, we will also need a way to reverse. So take actually carbon away from the atmosphere that has already been emitted. And BECCS is such a technology that will allow us to do that. On the right-hand side of this slide, you see a number of scenarios. The IPCC, the climate panel of the UN, they have concluded, or they have actually investigated what scenarios there may be in which we meet the targets of the Paris Agreement. So they have lined out around 70 or 75 scenarios of how we could do this, what kind of pathways to the solution are there. And what they see is that in basically all of them, you need negative emissions, because we will not be able to get rid of our present emissions totally, and we will not be able to do it fast enough. So in basically all cases, negative emissions are needed to be able to reach the targets of the Paris Agreement. And this is just an illustration of what I already said, but it's also important to line out here. There's a difference between BECCS and what we normally would talk about as CCS. Just quickly going through this slide. We are an energy company, Stockholm Exergi, so we normally work with biogenic energy production, and that is what you see on the left-hand side in this slide, where we actually have the trees absorbing carbon dioxide as they grow. We use the biofuels in our plants. The same carbon dioxide that was once absorbed from the atmosphere is emitted back into the atmosphere, and we have a closed loop. No adding of CO2, it's just the same carbon that goes around in a loop. What we do with BECCS is that we break this loop and we take the carbon out and put it back underground. So we're actually, in that case, reducing the concentration of greenhouse gases in the atmosphere. CCS, the concept of CCS, you normally talk about the concept of CCS in a fossil context. And in that case, you have some kind of production, maybe a cement factory or something like that. You take out fossil components that you use in your process out of the ground, and then you run your process, and then you capture all the carbon that would come out that would normally be emitted from that process and put it back under the ground again. In that way, you are avoiding any new emitting, but you have not taken any carbon dioxide out of the atmosphere. It's just making sure that no new carbon dioxide is emitted. So there will never be negative emissions from pure CCS. You need this biogenic component, or you need to actually take in carbon dioxide from the atmosphere in order for it to become negative emissions. So the project then that we are aiming to develop in Stockholm, we call it BECCS Stockholm, and we will then, in this, by putting carbon capture technology or implementing carbon capture technology on our largest bio CHP being a combined heat and power plant, we will be able to remove 800,000 tons of CO2 per year from the atmosphere. And 800,000 tons, is that a lot? Well, it's on par with the emissions from traffic in Stockholm. So it's quite a bit. And we will do this in a process where we also will recover the waste heat from this process to the district heating system that we already have in place in Stockholm, covering basically the whole city. So we will actually have no energy loss, more or less, in this process, which is making it even more, cost efficient and also sustainable, as we don't need to invest very much energy that we can't get back. We will invest a lot of electrical energy into this process, but we will get it back as heat, and we can use it for heating the city. Also, as I said before, we will use sustainable biomass. We are already complying with the RED directives, of course, and there will be no additional outtake just because we implement this technology. So no difference from before, it's only that we are capturing the carbon and putting it away. We are probably going to use the HPC technology that Martin told you about before. There are several reasons, but one reason is that it's good for heat recovery, and also It's a very environmentally friendly chemical to use. It's actually used in food in some cases. So it's a very environmental friendly chemical, and it will allow us to capture some 90-95% of the carbon dioxide and flue gases. And the fact that we are already with this plant located in a harbor location makes transport easy. So we don't need this middle step of trucks or trains or whatever. We can go by ship already from the start. So this is the technical project, but then we need the revenue. So we need funding. Martin already told you we are one of the 7 projects in Europe selected for the European Innovation Fund grants. So we have received or will receive 180 million euros to do this. That is unfortunately not enough. So we will need quite a bit more money over the first 10 years of operation, which is actually covered by the grant agreement. And then we are looking to get money from the Swedish government, which is also setting up a state aid program for biogenic carbon capture and storage. And actually there has already been 36 billion Swedish crowns allocated in the state budget for this over from 2026 to 2046, so which will be awarded over a reversed auction process, which is really bidding for the one who wants the least money to take the carbon away will get the money. So we will be applying that, and for that, and the first round of that auction will be is planned for. Well, grants will be awarded mid-2023, which would be in time for our final investment decision. So that is a key criteria for us to be able to move to final investment, that we also get money from the Swedish government. But even with the money from the Swedish government, we strongly believe that there is a need and also great willingness from the private industry to be part of this and to be able to be able to be part of this project and also to be able to share the benefits from this project. So we are working hard on establishing a private market or a market for CRCs, carbon removal certificates, and it will be a voluntary market to start with. We are kind of certain that this will over time develop into some kind of a compliance market, but at this point where we are right now, it's a voluntary market. But there is still a strong interest from large corporations, multinational corporations, to be part and to buy these kinds of instruments to accelerate their own journeys towards net zero. And at the bottom of this slide, you see the timeline that we are following. We already did a pilot. I will come back quite shortly to that. That one was the pilot plant we built and started to operate in 2020. After that, after proving that the technology works, we have since 2021 been in a FEED study to really lay out all the design and everything that is needed in this big plant in order to be able to launch the construction project. And that the FEED will be finished and finalized now in May. We will, after that, go into finish the last pieces of the detailed design and go into procurement to be able to reach the final investment decision in mid-2023. And that would then allow us to commission this plant somewhere late 2025 or in the beginning of 2026. And here's an illustration of the value chain. I think Martin already told you this is the same thing. So we will use the certified biomass. The biomass will be incinerated. We will capture the CO2 and also reuse all the excess heat coming out of this process in a district heating system. We will liquefy the captured carbon dioxide on site in order to make it more effective to allow more effective transport or efficient transport, and then we will transport the liquefied carbon dioxide on ship from the Baltic Sea to the North Sea. And we have not quite decided yet with whom we were going to cooperate on the storage, but it will be one of the projects that Martin has shown. And there it will be stored permanently, so that we can be certain that we will never see these carbon dioxide molecules again. All right, and I think Martin had this picture in his presentation as well. This is the demo plant that we have up and running at our CHP plant already today, capturing carbon dioxide from the actual flue gases of the plant. This is with this plant we capture around 150 kilos of carbon dioxide per day. The large-scale plant will capture 150 tons per hour. So there is a difference in scale. But still, it is very important. With this plant, we have been able to optimize the process to find, pressure, temperature, chemicals, whatever, how we shall operate this process to make it as efficient as possible. We have gained quite a bit of attention with this plant. We have many companies, politicians, policymakers visiting us more or less on a daily basis, but at least every week to see this and to learn from our experience so far. So, I mean, the idea of doing this is obviously to be able to contribute to saving the climate, but it's also very much, we are a private company, it's very much about business. So we strongly believe that removing carbon from the atmosphere is a viable business from which you can make money and from which you can create services and products that society will demand. So, I will come back to that, but we already today know that quite a few companies are working with different sorts of climate compensation in order to, apart from trying to reduce their emissions, they also want to compensate for the damage that they cause to the climate. And today we see a variety of different instruments out there, some of them better, some of them not maybe as high quality when it comes to do they really make a difference. But what this picture shows is that, okay, so over time, these instruments will gradually develop into just being removals with permanent storage. That is because that's what the climate really needs. Long term, we cannot only have short-term removal. So it will be gone for a few years and then it will come back. That would be no good. We need to take it away permanently. So over time it will develop into this. But where we are right now, we need to use all the tools that we have available, and that will be, different kinds of avoiding emission projects. It will be carbon removal with short-lived storage, maybe in a product, and then after 50 years it will be emitted again, and also CCS is what you have as number 3, where you actually do use fossil raw materials in a process CO2 and send it back. That will, as you can see, this is Oxford University has developed this slide, and as you can see, the prediction is that those technologies will peak, and then there will be less of it in the future, because it's really a really expensive way to do things, but we will definitely need it in this transition. And in this picture, it looks like it will go to zero. I don't think it will go to zero, because there will still be processes where we need it, and I think waste incineration is one of them. But anyways, it kind of illustrates the development that we foresee when it comes to carbon removals and also reductions. So we will, as a company, we will provide negative emissions as a service to the market, selling these CRCs. So any company that wants to accelerate their journey towards net zero, or in the end reach net zero, will be able to buy these instruments to compensate at the end for the residual emissions that they were not able to mitigate or to abate. There are different ways to address your climate footprint problem if you are a company. But we believe it's very important that you have a clear strategy for how you will go from where you are today to be able to reach the position where you are net zero and in compliance with the targets of the Paris Agreement. And there is help to get. There is, for example, most of you probably know of Science-Based Targets Initiative, which is an organization that helps companies to form plans that are in line with the Paris Agreement, so that these companies can set up their accurate plans for their reduction of their current emissions. And in the end, when they have identified their residual that they will not be able to get rid of, also to phase in these negative emissions to neutralize the residuals that they cannot reach. Because in accordance with the science-based target methodology, you cannot reach net zero unless you neutralize your residual emissions with carbon removals and permanent storage. So there is really no way, according to the science-based target methodology, to reach net zero if you only go for afforestation, for example, because that is not permanent. It's still up there. The carbon is still up there. Even though it's bound in the forests, there are scenarios when that carbon may be released, forest fires or whatever it may be. So the permanent removals of BECCS, and also there are other technologies like DACS, the direct air carbon capture and storage, are the only accepted technologies to reach net zero in accordance with the science-based targets methodology. And we will supply those instruments to the market to be able to do this journey. And in our case then, this is the way we are moving forward. We already received the Innovation Fund grant, and at this point, approaching our final investment decision mid-2023, we are now concluding the offtake contracts with the private market to secure the revenue from the voluntary market. In parallel also, obviously, we will apply for the Swedish state aid. So we believe that state aid, revenue from the voluntary market and the EUF grant, we need all the components in order to fund this kind of investment. So that's where we are right now, and anyone on this seminar today that would be interested in exploring the opportunities of buying these kind of instruments, you're very welcome to contact me for a further discussion. Okay, so Stockholm Exergi, we are not only a company with bioenergy plants, we also do waste incineration. So we Stockholm and the Stockholm area with waste treatment services, and we do this in a process where we also recover the energy, producing power and heat. But I wouldn't say that in our world the waste is not a fuel. The waste needs to be treated, and it would be very unwise not to take care of the energy content of that waste when you have a district heating network already in place. Because that's resource efficiency, more or less. And what you can see here on the graph that I have in this slide is that, okay, so after we have built this first BECCS plant, we will be on the first bar with 800,000 tons of negative emissions per year. After we have included our two major waste to heat plants, we will eventually reach almost 2 million tons of captured carbon in Stockholm. And then adding also our with other plant owners, we can go even beyond that. And as you see in this one, the pink and the blue would represent Stockholm Exergi. When we include the waste to energy plants, we will have a combination of a biogenic and a fossil content in this carbon dioxide, and that would require a different business model than the one that we have for our BECCS plant, because in this case, the fossil CCS we cannot make money from over negative emissions, because there are no negative emissions. That's a different kind of, that's fossil CO2. It will not be able, you cannot create negative emissions from fossil CO2, so you cannot sell CRCs to finance fossil CCS. So you need a different way to find your revenue. And we strongly believe that there needs to be policy in place that allows the polluter pays principle to guide us here, because the problem is that we are selling waste treatment services, as I said, to society. This is something that society needs. Lots of waste is generated in today's society, and even though, and we are also all the time working really hard to make sure that we get less waste that we incinerate. So we sort out. We are working hard. We actually built a new sorting plant that we took into operation last year. That will sort out all the plastics in the waste in one of our plants. And this is the direction we are moving in. So we are trying to get less waste from making sure that it can be what we throw away can in some cases already be reused. In other cases, we can at least recover or recycle the materials. But there will always be a residue also in the waste stream, and that will need incineration also in the future, we believe. So to take care of this, we need to make sure that the ones that really cause the waste are the ones that are to pay. And today, when we have waste to energy, for example, the carbon footprint of this process will follow, the carbon footprint will follow to the district heating customers. So the district heating customers are hit by the carbon footprint from the fact that we are recovering the heat from the waste incineration process. But they cannot really do anything about the composition of the waste. So we need to, in order to get rid of the fossil content in the waste, we need to address this problem to the ones that can do something about it. And those are really the ones that bring the fossil content to the market, the ones that put products on the market with a fossil content. So we believe that there needs to be a way to fund CCS on waste by taxing or whatever, some kind of a system where the money comes in from those who place products on the market that has a fossil content. And as high up in the value chain as possible. Preferably in the manufacturing layer, you know, where if you manufacture a car, there will be several parts in it, plastic parts, that has a fossil content. They should pay for the CCS at the end of the value chain, because they are the ones introducing it on the market. So, thank you.
Yes, thank you, Erik. Really interesting. I have a question. Can we talk some numbers now? How big is the investment in BECCS to capture this 800,000 tons of CO2?
The fee is not. It's going to be a multi-billion Swedish crowns investment.
So around 2 to 3 or
More than 3.
More than 3. All right. And the price per ton, how much do you calculate with?
We believe that we will need between 100 euros total revenue per ton stored carbon dioxide. So this money could come from then the innovation fund, state aid, and private market. But together we need 150 to 200 euros. That's our estimation at this point.
So do you have any questions from Erik? For Erik. From Erik.
How straightforward was it getting the carbon reduction credits?
It is not straightforward at all, and we are not there yet. But it's there are many obstacles still to overcome, and there are, first of all, there are legislative issues, but they are being addressed as we speak. I mean, there are problems today with when it comes to transporting separated CO2. You're not allowed to do that, basically. And also, so there are such problems that need to solve. Those are being addressed at this as we speak by the politicians, and we have. It's reasonable to believe that would not be a problem when we reach 2025. Then there are, other problems. I mean, as I said before, we need to establish this value chain. We haven't seen the end of that yet. We are buying shipping and storage as a service. Those projects are also under development. We hope converge in 2025 so that we are ready and they are ready at the same time. Otherwise, we need to wait until everybody's ready, right? When it comes to so that's the physics, so to say. But then when it comes to the actual certificates and the trading in the there are no market rules for this today. Now, closing their public hearing around the CRC mechanism. The last day to submit your answers to that hearing is, I think, 2nd of May, so it's very soon. We anticipate that what will come out of that process is a rule book, more or less, for this market to relate to. Because it will tell you what can be counted as a removed ton, and all these important decisions that need to be made in order for the market to feel comfortable that okay, so we buy this and we get this, So that is one thing, and then we need also to establish. This is like these certificates, if you are to trade them and to make sure that the environmental integrity is kept, so that there is no double counting, there is no such things that throws this in a position where it can be questioned for not being a good thing to do, and there are lots of things to determine in that space. There are many ideas of solutions, and there are several pathways that will take us to the goal, so to say, but there is no consensus which path to choose yet.
Not yet, but hopefully it will be. But then, Martin, I have a question for you. You have done several pre-studies or feasibility studies, and you talked in the beginning of OPEX and CAPEX. So what numbers do you see? Is it the same as Stockholm Exergi, or?
Well, yeah, I think that's what we see. Every emitter are different. What we can see is that big is beautiful. The more volume you have, desto the lower cost you have for transportation. But also the capture cost will be lower if you have bigger volume. Stockholm Exergi has a problem with seasonality. So you are emitting in the winter time, and in the summertime you're not emitting at all. So you have to have a ship that's kind of waiting, which is a problem that will increase the cost, of course, of the transport. So waste to energy plants are better in that respect because you burn waste all year round.
Yeah.
So you have a better transportation facility. But we see these the figures, and what is interesting, if you look at that diagram that we had before, they are quite low compared to a lot of other industries. I mean, transport, they are much higher, and a lot of industries are much higher cost for their emissions. So I think that both the biomass industry and the waste energy industry are quite good in the price range. But I have a question to you, Erik. How do you, when you talk about the buyers of the CRCs, how, are they kind of happy with the permanence, storing forever, and trees are only there for 60 to 80, 100 years? I mean, how is that dialogue going? I mean, do they accept this permanence or what?
Yeah, I think that the idea of geological storage being permanent is more or less accepted. And I mean, it has been proven in many scientific reports that, plus 99% will remain after 10,000 years or something like that. So it's that is accepted. I mean, then there is a difference. I mean, obviously, technical emissions like BECCS with negative emissions with permanent storage are much more costly than, for example, afforestation projects. So there is a policy difference between different companies. What kind of carbon or what kind of climate compensation instruments do they want to work with? And there's an economic aspect to this, and there is a sustainability aspect and a policy aspect. So every company is different. There are. And it's still a very immature market. Most companies, even though they have set net zero targets, they have no clue how they're going to reach it. So that is very common. Whereas others, and they made their carbon pledge a year ago or so, saying that they will be carbon neutral by 2030, and then until 2050 they will have reversed, taken and they will increase the volumes that they buy the coming years, going to up to 2030, and from then on, when they are net zero, they will start to work with their historic burden, so to say. So I mean, with Microsoft maybe on one end with a very ambitious and thought through plan, then you have all the others in some kind of a line, and the ones we talk to are the mature ones that really have high ambition and that see that we cannot be content with buying instruments of lower quality than what you can find if you look for the best. So the ones that talk to us, they understand that this is going to be more expensive, but we are buying the best that there is to get.
Will you put your carbon credits on the market also? Because we have read the last week that Nasdaq has put carbon credits on the market. Will you also do that for some of your CRCs?
Yeah, so I mean, our position is that we would like to sell as much as possible. We are not, as a company, we are not aiming to reach net zero by keeping these credits. We will reach net zero by reducing what is left of our fossil emissions, and much of that comes from the waste. So we will not use BECCS to compensate for our waste carbon footprint. We will improve our waste processes to reach net zero on that, and then we will be able. So we will look to sell all the credits that we will generate from this BECCS plant to the market, because long term there is no reason for us to keep them.
There was this big dairy company in Sweden who for at least 2 or 3 years put on every milk bottle that they were carbon neutral.
Yep.
And they were actually the market some kind of facility told them that they had to take it away because it was not in line with reality. And I think that's kind of interesting that they had to do that, because they were kind of telling the market the wrong thing.
Yeah. And it's very important, I mean, to have this environmental integrity. I mean, once you make a statement, it's kind of complicated to understand what you really are stating when you do that. So there needs to be some kind of a standard in place, and this is what the CRC mechanism that the European Commission now is working on is going to be there for. So for the market, you don't have to be. You can't have to be a expert in carbon removals to understand whether what the market tells you is true or not. So there needs to be some kind of a standard that everybody complies to, so that everyone can understand if I or is it not.
Yeah. Okay.
But I think one thing that we need to add here is that we have these targets to become climate positive in Sweden and also in the UK. And I think it's really important that we stay positive, because they are also within the EU, they are beginning to take these targets also. And I think in Sweden we have the potential to capture about 30 million tons of CO2. And you mentioned something about large to bigger, but I think it's really important that it's small scale, middle scale, and also the large scale that are on this journey, because we have the potential. We have waste to energy plants, and we also have CHP plants with bioenergy. And I think we all needs to help with these types of carbon sinks for every country in Europe to reach their targets. And by the small scale, you have this pilot plan, but maybe you can develop some kind of container solution. So I think maybe in the end, it will not matter if you're big or smaller. But I was thinking about something else, collaborations. You talked about collaborations also. And if you divide the price of the capture and also the transport, is it 50-50 divided? So 50% is the cost of the capture part, and 50% is the percentage of the transport part.
Yeah, I mean, in our case, then our investment will only be the capture plant, the liquefaction, and the ability to load a chip. So that is our investment, and the rest we will buy as a service. And in this setup, our cost for capex and opex will be less than half of what the total cost will be. So more than half will come from transport and storage, the way it looks like right now.
And you have told us this many times about the transportation costs.
Yeah. Absolutely.
And we as engineers, we are always focused on the technology. It's really, really interesting. But it's really important for the transportation and the logistics that it works. And we also talked about these collaborations within logistics. That is also an important part, that you find other waste to energy plants that maybe you can collaborate regarding storage or transport.
Exactly, and then you need to coordinate your timing with them, which is otherwise one has to start one day and the other guy comes next year.
Yeah, that's good. But maybe someone could be the first, and then they can prepare for the next one.
Absolutely.
Everything is possible, isn't it?
Stockholm Exergi has been. I can say that in Sweden, everybody is following because you started it.
Yeah, and I think that, the numbers that I just gave you are obviously based on the fact that we are a first mover.
Yeah.
And at this point, it looks like this. Transport is more than half, transport and storage. Long term, the cost of transport and storage must come down significantly, and we expect it to. And the way to get there is not by from every project working, in their own tube, so to say, but projects working together. So when it comes to transport of carbon dioxide from the Baltic Sea to the North Sea, for example, we need to look at hub solutions where we collect the carbon dioxide locally here, and then using as large ships as possible, transporting it to the North Sea. And I mean, eventually, over time, I don't know, I mean, as this industry grows, I think we will see more and more pipe systems for transporting carbon dioxide, because that's really the most rational way to do it, and the best way for the climate, not having to use ships with fuels and stuff like that. This will develop over time. But we already today see that when we set up the transport and storage value chain for our project, we will probably need to look into the future at the same time. We cannot just set up a value chain for this single project. We need to try to find partnerships that will be based on other future plants coming into this equation as well. So that we will start building a value chain that is scalable, not only for this project, but for anything, all projects around the Baltic Sea.
And we have different other projects also in Stockholm.
Definitely.
Yeah.
And in Sweden in general, and in Finland, and in the Baltics.
Yeah. And that's really great, and we love them. More projects within this field. So how is it in the UK? How many waste energy plants are there approximately?
I think there are about 70 or 80 in the UK. Something of that order, yes.
Yeah. And it's time for you.
Transportation, which is an issue.
But you will talk some numbers also, and you will be positive now.
I'll always try and be positive.
That's really good.
Okay. What's happened in the UK and in the world in terms of the changes that affect the energy from waste market? The first change was the introduction of carbon cluster strategy, which started off, first mentioned that I could find in Poland in December 2018 at a COP26 planning session. Subsequent to that, there was various announcements made. There was 19 about how this might look and how this might work with, draft contracts were circulated for comment and consideration. Responses were sent back, and the government responded in 2020. And then in October last year, they announced that the first two clusters to be taken forward, plus one reserve, had been selected based on the submissions made. The two that are going forward, of course, are the HyNet and the East Coast cluster, which consists of one in Teesside and one in Humberside. And the reserve is the Scottish cluster based up at St Fergus, which is one of the main pipelines taking carbon dioxide out of the North Sea, and that's becoming a separate business for the entity that's based up there, which is called Sorega. Moving on from that, the government issued its biomass policy statement in November last year, and I've just put 5 key points which I think are going to affect energy from waste plants as much as in the same way as anybody else, and possibly these are almost quotes coming from the statement itself. So this is the government's words, that CCS will be required for large-scale biomass-based generation. That's not just energy from waste, that's anything. They're looking to get negative emissions from the straw burning plants in those parts of the world which have lots of straw, like up in Norfolk and places like that. Second point was about enabling intermittent renewables, and what they actually said was they need energy from waste and dispatchable generation to support the intermittency of renewables. But there's another reason for it as well, and it did affect the UK a few years ago. Intermittent renewables can't support frequency on the network. And since most of the offshore wind now is attaching to the national grid, the transmission network, whereas hitherto all of the onshore wind generation was was going into the distribution companies who were able to pull down power off the national grid when they needed support. The national grid is somewhat vulnerable now to trips on large-scale wind farms, so they need dispatchable generation to support the frequency. And dispatchable generation, I mean, the best things are nuclear and coal plants, obviously, but coal plants are on the way out. The steam turbines on combined cycle plants, they can help support as well. Energy from waste plants support as well. So it's a, you know, the more wind we put on, the more support we're going to need to make sure that the grid, the transmission grid, remains stable. I think that's quite an important point. Another point is that energy from waste plants are a source of fossil-based emissions. The government is assuming that approximately 50% of the waste stream is biogenic, so 50% is not. And the non-biogenic part generates emissions from fossil-derived fuels, such as plastics and things like that. So carbon capture, to remove all of the carbon, will do several things. It will get rid of the non-biogenic part and also the biogenic part in equal measure. So energy from waste plants could also generate negative emissions, and that could give rise to the possibility of carbon removal credits as a separate income stream for these plants as the market develops. And finally, there's another comment in there which I felt was a bit of a stick. You know, there's lots of carrots to incentivize people to do things, but this was the stick. It said that EU ETS may be a market-based solution. In other words, if you choose not to do this, then you could find yourself in the ETS system and having to buy carbon credits to cover your emissions. And they've been trading up around the £75 mark for a little while now. So it's an expensive solution, but it's something that has to be considered in the context of looking at the economics of the plant and what you're going to do to the plant as a whole.
There's actually opted in on ETS for waste to energy, so we are already in the system.
Yeah.
Yeah, we are.
Personally, it's a personal view, I think it will happen. I just don't know when.
I think it must happen.
I think so too. Okay, next was COP26. That's pretty straightforward. That's a big meeting in Glasgow. The plan is to retain global temperatures to no more than 2% with a target of no more than 1.5%. After much debate at in the final hours, it was agreed that they would phase down coal generation as opposed to eliminate it. And the 140 countries signed up to net zero emissions at some stage in the future. So there's a global commitment to do something about the carbon dioxide in the atmosphere issue. Next thing I'm going to talk about, and it's something Martin alluded to, and it's something that Erik mentioned as being a significant cost element. It's a big cost element of having a carbon capture plant. Location is the key factor. If you're by a port, it's relatively straightforward. If you're inside a cluster, it's relatively easy. You should be able to get hooked up. But if you're not inside a cluster, then you've got to look at transportation to move it around. And it's not as straightforward as it may seem. You know, I'll talk a bit more about this, but the message is that you do need to study this in detail to make sure you actually get the optimal solution, the lowest cost solution for your transportation needs. Not just now, but looking forward in the future as well. They're the transport considerations that, you know, you can use a pipeline if you're in or very close to a cluster, and that's where the clusters are in the UK. Road is a possibility also. I've not put a map of the roads up because I think everybody is as familiar as everybody else with those, but there's basically 2,300 miles of motorways and there's 28,800 miles of A roads, which are probably the only ones that are going to be suitable to transport carbon dioxide on trucks, on containers, or on large lorries or something like that. The rail is something different. That's a brief map of the rail network, but the key point about that is that there are 7 businesses that deal in freight transport on the rail. There are 4 relatively large ones and 3 smaller ones, and they all work together. They're all in competition, which is a very important consideration and a valuable consideration, but they can all move this stuff around, and they move all sorts of things around on the rail, including, believe it or not, waste going to landfill was one of the things I found out about. They can move nuclear waste, they can move large scale, large biomass movements. Obviously, they used to move a lot of coal from ports on the coast to coal burning generating plants inland. Now, what that means in the current environment, with less coal being burnt, is there is capacity on the rail network. So it should be a good time to be talking to these people about, we need to do this for a long term. A thermal plant typically has a 40-year life in the UK, sometimes longer than that. So it might be a good time now, with the coal having gone down, the capacity on the rail network having come down. These people are going to be looking for something to fill the gap. So it might be opportune, maybe. There are also a series of intermodal hubs in the UK. An intermodal hub is a hub that basically uses containers to move products about. And the idea is you can take a container off a lorry, put it on a train, and then put it on a boat, and then move it all away. And there are intermodal hubs inside the country, and I've tried to colour those green on the map, although it might not show up very well, although hopefully when people get this and can print it out, they'll be able to see it a bit better. But also at 10 seaports around the country. So, there are major ports that are geared up to deal with this sort of thing. It's difficult to know how the transport's going to emerge, but one thing that I have heard is that people are already looking at container-based solutions to carry carbon dioxide around the country and to the ports. Once you get it on a port, you put it on a ship and you take it to somewhere like Peterhead where they can put it into the ground for you. I've also heard that people are starting to think in terms of aggregation. There are aggregators starting to put business plans together to say, well, if we can get people to get it to the coast, we can pick it up there, we can take ownership of the carbon dioxide there. Hitherto, at the current time, any carbon dioxide you emit is under your ownership until it's placed under the ground in storage, for which you're paying. So aggregators would basically pick your carbon dioxide up. They would arrange with other emitters to transport their carbon dioxide to places like at ports where they might build buffer storage facilities, organise all the transport, organise everything like that. Now that might be an elegant solution in the fullness of time. We'll just have to see how it plays out. My instinct tells me that right now it's probably going to be relatively expensive as they get the business models built up. So for the time being, we have to do these studies and look at what the transportation options are to try and come up with the lowest cost for the plant, for the customers, and for the people who generate the waste. Because ultimately, if we can't do that and the costs of the energy from waste plant go up, ultimately it's going to get passed back in the gate fee. Otherwise, these plants are not economically viable and they'll have to close. And that's a much, much bigger problem. And we don't even need to think about that. So that's a little bit about transportation and the business environment. I'll take any questions here on that, and then we can open it a bit more widely.
Yes, thank you. I think it was really great with these clusters and that they have thought about it. Who was the initiative taker for these clusters?
I don't know. It was the government that first started talking about it in 2018 at the COP26 planning session in Poland. So the government must have been talking about it. So its advisors must have been considering it, which is good because it was only a few years before that they actually had 3 trial projects for carbon capture and storage up and running in the UK, but they just cancelled them. They just cancelled them almost unilaterally at the approximately the same time. 2 were funded by the UK government, another one was funded by the European Union. Personally, I was involved with the one that was funded by the European Union. But they decided not to go ahead with it, which is a shame. There was one existing gas plant, there was one existing coal plant, and there was one new build combined cycle gas plant. And they stopped it. Yeah.
But you also mentioned the location, and they need to do their own pre-studies because it's different from different waste-to-energy plants.
Every location is different.
Yeah.
And that means every transportation problem, for want of a better term, is going to be different. That's something we get involved with. We have transportation experts who study all of the permutations and look at all the possibilities. You know, is it cheaper to take it to a port where a port which is closer and cheaper, and get somebody else to pick it up and deal with it bilaterally as opposed to through an aggregator or something like that. So we look at all the permutations for transportation and come up with the optimal solution for the plant. And that's not to say it won't change over time, but you know, when you're putting these things together, you can only go with what's available.
But they can contact you also regarding both carbon capture and the logistics and transport.
It's part of the service we provide. The studies on transportation is one of the elements that we look at.
Yeah, great. Do you have anything to add, Martin? Number 2.
I think the cluster thing. I mean, England, just to go a little bit of history. I mean, Norway was really early, England was really early, and Germany was really early in this. Sweden was actually not. We were not involved at all. We were very. I mean, we were involved in Germany in Vattenfall, of course, but history of his CCS, but we all saw this desert walk between 2009 and 2015. So that's what that's what closed down everything. So there were 13 NER 300 projects that was funded, that was supposed to be funded by the European Union, and none of those 13 was actually executed, because I think it was also a question about it was strange, and there was no storage.
Yeah, but we gain a lot of knowledge from this project.
Absolutely.
I was working at Vattenfall, and they had this Schwarze Pumpe, so still we got a lot of...
Absolutely.
And I think that part is great. Now we have to be positive, because it isn't impossible, is it, for them to start a CCS project? But it requires a lot of work and many years, as you mentioned.
Yeah, I think that, until a few years ago, a lot of people thought it was very expensive. I mean, much more expensive than what you're talking about. And now what we realize is that first it's feasible. I mean, technically feasible, and it's not that expensive. If you look at the list there, I mean, we're talking about 100 or 100 and whatever euros per ton, between 100 and 200. But if on that list, if there were 1,000 euros a ton, if you're doing something else, so. It's still on the low side, so I feel that carbon capture and storage, or BECCS, bioenergy, is quite low cost actually.
And I believe, I mean, cost. This is still a fairly new thing. Cost will come down, just like we have seen with solar panels and stuff like that. I mean, the technology will become cheaper, but I also think that. When it comes to waste treatment with incineration, I think that we need to be ready for a situation where that will not be possible without CCS, because it's very hard to see that we can allow ourselves to have carbon-emitting processes from when it comes to waste incineration when we are approaching the net zero target. Because that is not what is the hard-to-abate emissions. There are other emissions that are hard to abate. Emissions from waste incineration is not part of hard to abate. So we need to find ways to get rid of that. That is reduction.
All right, we have one question here from the audience, from Frida Jarrå. Why did they cancel the CCS projects in the UK, and how can we prevent this from happening in the future? Martin.
Well, they just decided not to proceed with them. They were working away. I don't know whether I wasn't involved with the two that were funded by the UK government, or whether it was the costs were getting high. I think possibly not. It was just a policy decision, and governments do that.
And wasn't it also an issue with the acceptance part?
I never heard anything about acceptance. I think people would have been very keen to see
Germany.
it.
Yeah, but maybe that one affected the UK also.
Actually, this Don Valley project, it was very close to the Brexit thing as well. So that was one of the things. All of a sudden, the European Union, they didn't know about, because it was funded by European Union.
Yeah.
And then I think the main problem was actually the mechanism of the NER 300, which was then, a lot, and the mechanism of the funding and the lack of storage. There was no storage. There was no storage sites.
Well, they'd found a saline aquifer for Don Valley, and that was also going to take the CO2 from Drax. Peterhead up in Scotland, I think they were going to put it out where Storegga are working now. So I think they found the storage sites, and I know on Don Valley they'd spent a great deal of money in investigating the saline aquifer, because that was EU funded, and it just... Well, the EU pulled out about a week after the Brexit vote.
But the future now, how can we do in the future so it doesn't happen again?
I think that, this is obviously a challenge, introducing new technology and new industries is never easy. But what we know is that climate change will not go away.
No.
So, we really have to do something about this. Where we are today, the scientists have shown that they are pointing at the paths we need to follow in order to be able to reach the targets of the Paris Agreement. Those pathways include massive reduction of emissions, but they also include negative emissions. So it's we don't have very much choice, I don't think. So it's going to be even more costly not to do anything.
Yeah. Yeah, and I think it's really important about these targets that you are becoming climate positive and how to reach it. So, as you mentioned, there are no other ways because yes, we can reduce our emissions, and then we have these other emissions left from the agriculture. For example, and we can't like put a bubble over all our agriculture stuff in Sweden, for example. So we need these negative emissions, and that is the best way is from BECCS, because it's also more efficient and also waste CCS than it is, for example, if we were thinking about direct air capture with bio-CCS.
Yeah, today, I think we will need both.
Yeah.
Because we are not in the position just to choose to pick the cherries, because we need them all. And also BECCS. In Sweden and in the Nordics, BECCS is very relevant, as we have a large forest industry and lots of residue from that industry. We are not going to cut down trees just to do BECCS. The idea about BECCS is to use the residue materials that will come up from other processes and make as much value from that as possible. In other geographies where you don't have a large forest industry, then DAC is going to be the technology to choose. And yes, the concept of DAC, you can easily see that placing some kind of a DAC unit out at sea, offshore, with a solar panel, and you're standing right on top of with the place where you want to store. That could be quite efficient. Today it's more expensive than BECCS, and in the future we're going to need both of them.
Yes, and we have a question here from Linda Owens, and she's asked about CCUS. Why don't we talk more about CCUS to use the carbon dioxide?
Yeah,
I think the answer to that is it's a big subject all of its own, and we feel it merits a separate session to do. We'll see how this session is received, but the plan would be to start thinking about how we can use the carbon dioxide in such a way that it's permanently removed in such a way that not necessarily
US is one thing, CCU is another. I mean, our carbon dependence will not go away. I mean, we will need carbon. There is carbon in our clothing. There is carbon in so many things that we take for granted. Even though we stop running our cars on gas, we will still need carbon for other things that happen in our society. The way is that we need to find sustainable carbon, establish those, and one way to feed these cycles with carbon would be to capture it from the air and then use it, and then so we create these loops again, just like the biomass energy loop would look already today. But we must stop taking carbon out of the ground.
Yeah, that's really important. And we have the next question here from Ryan. I don't know which Martin, but do you foresee any major challenges within the permitting process than looking to adopt CCS at EFW plants in the UK? Is it you or is it you? Who will?
Shall I start?
You start.
Okay.
Continue.
I think within the permitting, I mean, in the biomass statement, it said that large-scale biomass projects would not be considered without CCS. So in terms of the permitting process, it could be argued that he thinks is the right thing to do. You'll probably find that fairly easy on in the planning stage. The question is, what constitutes a large biomass plant? That's not defined. So it's very difficult to know whether it's 100,000 tonnes a year or whether it's got 250,000 tonnes a year. Where is the cut-off point? Because carbon capture is expensive in the terms that there's certain fixed elements of stuff that you have to have. And if you have to have them at a large plant, you can amortize the cost much more easily than at a small one. So I think a bit more clarity from the government will be welcome from that, and I'm sure they've issued a policy statement so far. They'll probably come out with some further guidelines and rules at some stage hopefully, because the last thing people want to do is be planning one of these things, thinking about the permitting process with the uncertainty of what do they actually want and what is actually going to be required.
I have a little bit on the permitting. What we have seen is that, first of all, you have to plan for the permitting, because a permitting is always like, it's like very difficult to understand what it will be. But so you have to plan for the permitting. But what we are seeing is that the permitting detailed, which means that you cannot answer them too early. So you have to come a certain way in order to be able to answer the questions in the permitting process. So it's like in your project, it's a moving target about planning it, but also a kind of until you have come maybe into pre-feed or feed for certain things, heights and volumes and stuff like that you may not know until later on in the. But permitting is always difficult, right? It's not more difficult here than in any.
No, but I think what may be a challenge in this case is that also the authorities are not used to this technology, so they don't have their process yet, and this will also mature over time. So from a building permit point of view, it may not be a very big problem. It's just like any industrial facility. But when it comes to the environmental permit and the whatever permits you need to operate such a plant, it's a different story. You need to at this point you need to educate the authorities when you come in with such an application.
Yeah.
And we have another question here from Jaco. How important is social acceptance? I'm looking at you guys. I
would say very important.
Yeah, it's really important. I also think that. And that's why I was mentioning before regarding these projects within CCS that you have the communication part. And also it's good for the business to maybe get financial support from some industries or companies or real estates that are near your plant.
But it's the question is that it's a social acceptance. It's very important in a positive way compared to in other. You know, in the early days of the CCS, it was people were afraid that they were, bury the CO2 in their backyard, which was negative. But now I would say that most projects are in a positive. It's a positive social acceptance.
Yeah, that's good. Do you want to add something? How is it in the UK?
How is it in the UK? I think people are realising that something has to be done.
Yeah.
And this is something that's not a reason why you should do it, but this seems to be well conceived this time, and it seems to be a sensible way of dealing with the problem that is being faced.
What is the reaction from the people in Stockholm, your plant, and so on?
We work a lot with social acceptance. That is one of the enablers in this case, and when it comes to scientists and that part of society, it's not there is already acceptance that these technologies and that negative emissions are needed. When it comes to first of all, not very many know of negative emissions and CCS. It's not like maybe the prime interest of most people. So there is still lots of communication to be done, but I think it's really, really important that we understand or find ways to get a broad social acceptance for these technologies as the climate will probably. We don't know any other ways to tackle the residual emissions that we will have even after we have reduced what we can reduce.
And you also had the support from Stockholm as both an owner, but also as a municipality. What is it?
Yes. Stockholm, the city of Stockholm being one of our owners, they are very positive to this for sure, and it will also contribute to their environmental targets. So Stockholm as a city has set a target to be climate neutral by 2040. So. Our success is kind of, they're depending on our success, I think, because they will look at Stockholm from a territorial perspective, and they are aggregating all the activities that happen on their territory. And obviously, if we produce 800,000 tons of negative emissions on their territory, it's an important contribution. So and it's I need to, in this case, it's really important also to emphasize, if there are any in the audience that are really into the carbon accounting aspects, that Stockholm City, no city has a firm, there are no NDCs like in the Paris Agreement. You have your national determined contributions for each country. There are no such thing for cities, so it's not about double counting. But they will look at this at the same way. They will still do it the same way, even though there is no formal accounting for a city.
Yes, I see that we have a lot of questions. You have sent that you can email them to Captimise, and also we are going to have a time maybe to have a Teams meeting and to meet each other, and then there you can also ask us the questions and then we can discuss them. But you will inform all the audience later on. But I think the most important thing now, the audience, they need to bring something from here. So can you all mention just one thing that is really, really important for CCS, to implement CCS in the UK? Should I start with you, Erik?
Yeah, absolutely. I think UK or not, but in general, I think it's very important that any business owner, any operator of an industry starts thinking about how to comply with the Paris Agreement. You need to have a strategy and a plan, because it won't just happen. So there needs to be a plan. One way to do this is by using the science-based target methodology. There are other ways, but in the end, we need now to start planning to reach net zero by 2050. And when it comes to negative emissions, we will need those to reach net zero, but we cannot wait to implement these technologies until 2050, because then they won't be there in time. So we need to start planning now, and every company, every city, every country needs a plan that they can follow and track that they are on the right path.
And you, Martin, what is your...
I was not going to say the same thing, but I was going to say that start planning for BECCS and CCS, but do not jump to conclusion. Do your homework, do the studies, and don't jump to conclusions.
With your help.
Yeah, of course.
Yes. And the other Martin number 2.
Finally, there's... carbon capture is probably here for the time being, and that's a good thing. Carbon capture and usage is probably going to be a good thing as well. I think there is a need to embrace this now. I think the government is committed to net zero 2050. This is one of the courses it's chosen to take, and it needs to see it through. So we need strong government support, and I think they need to look at the financing side of it as well. These projects are going to require significant investments, and the banking community, the investment community. We did invite a number of people to join this webinar today, and we hope they found this useful. But their role is very important, but we need the government to set the environment where they can invest, to provide the money to bring these projects about, to allow us to get to net zero by 2050.
And I would like to to add 2 things also. I think collaborations is really important. That's one part. And the other part is that we are optimistic because we have a lot of alarmism regarding the climate. But here we have the solutions. So I think those are the 2 most important things. Not most important things, but one of the important things. But I think that, yes, you were going to abrupt me, or... No? No? You were just breathing. But from here, from Sweden, Stockholm, we would really like to thank you for being with us these 2 hours. And as we said, you can contact Captimise, both in the UK and also in Sweden. And thank you, Erik, for being a guest here. But we will follow this up and have a session, a Teams meeting, and then we will also be able to answer all the rest of the questions, I think, because I see that it is a lot. But thank you all, and some words from you, maybe, in the end?
Yeah, no, just it's been a pleasure being here, and I'm very glad that Erik came and Martin came from the UK, so thank you, everybody, for joining us. And thank you. Of course.
You forgot me.
No. I was going to end, of course.
Yes, of course you were. But we're saying goodbye here from Sweden, and take care, and we will send you more info. Bye-bye.
Thank you.
Thank you.
Bye-bye.
Bye.